Friends, this is Siri from Siri Tutor Blogs. So today we are going to talk about some more examples on lambda expressions. So in our last session we have discussed about functional interface, function lambdas and bifunctional lambdas, and how functional interface can be invoked using lambda expressions, and also how we can using multiple multi-threading concepts in lambda expressions and collections. So today we are going to see on objects, how we can implement on objects. So before diving into lambda expressions, let's simply understand how we can create an object, how we can print it, how to manipulate with the objects, and then we will step into lambda expressions. So for that, I have already created a Java project, and I'm going to create a class here, employee class, and then I'm going to just declare some properties here, ID, name, and salary. Salary should be in double or decimals or floating, but that's okay. I'm going to take this as integer. Uh, so let's create the constructors. Um, let's create the constructor and let's try to print it. And let's try to create an object of this employee class, and then let's print it. Okay, BJ. Was it? Yeah, we have to give some um, variables values right here. One silly and okay. If you print it, we are going to get in this way because we haven't override the toString function. So let's do that. Let's override this toString function here. So when we override a toString function, we have to give a return type as string, right? And then return ID, name. So this is a concatenation symbol that we use. And now let's print it. It's printing as we expect. Okay, now let's um, create an object using tree set, and then we'll give some values into the tree set, and let's print it from the tree set. Okay, and we are going to take employee as our tree set type. T equals to new tree set of employee. Okay, and then yeah, we have to import the packages, if not it's gonna complain. And then we have to add employees. Okay, 101 Siri, salary is 10,000. Okay, let's add few more employees here quickly. One or two. There is a comma missing, right? Raj, 4,000. Bhavani, 6,000. Vijay, Uh, Vijay is maybe 8,000. Okay. And let's print it out. This is out and T. Okay. And it's supposed to print this thing. Yeah, it is complaining that there is no comparable method because tree set has the implementation. So when we write, we have to implement comparable. So for that, let's implement comparable method here. Comparable employee, and then I don't remember the method. It's to char or something. Yes, it's to char. We have to override this method, to char method, and then yeah, to char method. Now let's this dot id. Let's take the current object id and then put it in current id and then convert the object into an employee type and then assign it to an employee reference just say E, and then declare second ID which has this reference ID. Okay, let's okay, then let's compare it. If current ID is less than second ID, then we are supposed to return a negative value. As I mentioned, as I explained last time in the last session, if the ID, we are just comparing, according to the ascending order. So the smaller ones will come before. If it is coming before, we are returning -1, and if it is bigger than like if it is a bigger number, we are just putting it in the we are returning a +1, and if it is both of them are equal, we are going to return 0. That's it. So we have to make sure that we are not giving any similar equal values. If we give it, they are not going to display. That's it. Yeah, this is pretty much it. So yeah, we got I think oh yeah, because see, if I told you that if there are similar values, it will not give us a desired output. So that's why it's not giving us, even though it's not giving us the desired output. Is there anything that, oh yeah, we have missed the condition statement here. So that's why it is not behaving as expected. So we got all the values. Okay. So this is when we don't, we are just using comparable interface, and we have implemented in our class. And as an object, as a creator of this object, we are responsible in implementing the comparable object. Comparable interface, sorry, it's not object. We are responsible in implementing the comparable interface and override the comparative method. So we are responsible in overriding it. If we are so by default, everyone, the objects can be sorted on based on the IDs. If you are not satisfied with the IDs, you can go with the, if you want to sort according to the name, then you can come up with your own implementation class and implement comparator, and you have to override compare method. So we are going to do that one as well. So let's see how we can do it. Let's implement our own comparable method, comparator method. So my comparator class, we have to say class, okay? uh, Class my comparator implements comparator of employee type, okay? And then I think it's complaining because we have to import the statement, and then we have to override that method, okay? Mm, okay. It is giving us two variable object variables. So let's assign these variable names uh, to the string variable, and then we'll compare it. O1 O2 dot name, okay, and then return S1 dot compare to. So we are in turn again calling comparative, because comparative is going to give us default alphabetic order sorting. So we, instead of reinventing the wheel one more time, we can just simply call that method, which will give us in an alphabetic order, right? So that is what we are doing. And then I'm gonna simply copy paste this, and then so guys, we are not at doing any lambda expressions yet. We are just simply seeing how the objects can be manipulated using collections, how we can use collections in our own objects. Okay, so just bear with me for some more time. I'm gonna jump into the lambdas very soon. So here we have to give, if we are not satisfied with the natural sorting based on the IDs, we have declared. Sorry guys, yeah, sorry guys for the interruption. Let's quickly, where are we now? Where are we now? Okay. Yeah. So we are trying to implement the tree set sorting method based on the names, right? Based on the names. So we have implemented this, and then what are we supposed to do? We have to give this. We have to give this this class which has implementation for the comparator, and yeah, that is pretty much it. That is how we sort based on the names. uh, I was not quite sure why why it didn't sort. Let's see why it's not sorting the things. Uh, yeah. So, in my comparator, I have implemented based on the names. Yeah. And we are returning based on the names, correct? And then we have we are just printing T instead of T1. So that's why we are getting the same output. Now we are not getting anything at all. I think um, the reason why we are not seeing any output is uh, I think we are supposed to do it like this. Sorry, because uh, when we compare things, um, yeah, let's write it a if function here, and then we'll go from there. Okay. I think it should do it. Why it's not? Why it's not able to do it? I have implemented one more method here, one more class. Let's take a look at it. Where is it? This is where, okay. Based on the ID. Yeah, that's pretty much it. That's how we implement. Yeah, that is what we did. And why is it complaining? It's not liking the thing how we did. So return. Oh, this is pretty much it. Compared to times comparing S1 and S2, right? Come on. Okay. So what is the problem here? Okay, let's copy. Let's copy instead of wasting the time here. I don't want to. What's wrong with this? It's the same, right? Hmm. It's the same. Okay, then I think there is nothing problem with within this thing. Instead, uh, T1 my. Oh yeah. Oh no. See, it's again the same wrong thing we have done. We have declared a variable here, and we forgot to update the list there. So now we got all the values in an alphabetical order. Okay, so this is how we have to do when we create our own object, and if we try to sort it, we have to use it if we are not satisfied with the comparable method which is inbuilt in this class. We can come up with our own my comparator class, and then we can sort the names. um, but just an idea I have, if we want to sort the salary and if we want to retrieve the second highest salary based on the second highest salary, how can we do it? What is the way of doing it? So for that again we have to, so it's our own implementation, right? It's our own requirement that we want to sort, we want to get the second highest salary, and for that we have to sort salaries, and we have to, after sorting the salaries, we have to get second highest salary, right? So for that also, for that we can just what we can simply do is, instead of id, we can implement, we can replace this with salary. Okay, guys, I am not changing all the variables. I'm just doing short fixes, quick fixes, so that it will be um, yeah. So what I'm saying is, I think I got an idea. Let's not do this. Instead, what we can do is, we will jump into lambda functions here, and then we'll just implement using lambda functions. Okay, let's do that. So for this one, what we can do is, what is the exact lambda function that we can use is based on the IDs, right? So let's leave this alone, and let's create another object. Now I'll remember this time to rename each and every object, not to forget that. And then, uh, in my comparator class, if not, we'll do another thing. Let's create an array list. Okay. Mm, let's do it right away here itself in my comparator. Um, in my comparator, I'm going to change the salary part here. Oh, again, now we have to take int. Okay, let me not erase all these things. Maybe I will reuse this later for my reference. Okay, int sal equals to, for the salary part, I think what we can do is o1 dot salary, and the same thing, sal1, we'll say sal1, and int sal2 equals to o2 dot salary, and then return based on the salary, right? It's very simple, not complicated. Based on the salary, we are why is it complaining? Cannot invoke compare to on a primitive type int. Oh, okay. We cannot. So int is only for strings, not for. Compared to is only for strings, not for integers. That is what it is complaining about. So what we can do is, let's declare my comparator object here directly. Let's jump into the variable. Let's leave it alone, this one. Okay. Okay, let's come here. And what we're going to do is we'll create an object of this variable. We'll declare array list of employee type. Okay. Okay, employee type list equals to new array list of employee type. Okay, and then let's import it. Why is it? Yeah, I have added this one, employee. Okay, so many mistakes. I do lot of typing mistakes here. Okay, all right. Now we'll add everything to L. Okay, let's add everything to list instead of a tree set. Okay, this time these guys are calling me multiple times. Let me complete this session and then we'll worry about that later. Okay, so I have added all the employees here, and then uh, I'm going to um, print it. And then what can I do now? Now I can just create collections dot sort of uh, list object, and then I can simply say, I have two objects coming from E1 and E2, and then what I can say is the lambda expression with E1 dot salary, if it is less than E2 dot salary, then question mark. So then means question mark. Then I'm gonna print +1 because we are finding the greatest element first, the largest salary, the person who is getting the largest salary. So instead of -1, I'm putting +1, and then else if E2 E1 is greater than E2 dot, oh sorry, E1 dot salary greater than E2 dot salary, then 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 it is question mark, right? Then print -1, else 0. Okay, okay. uh, yeah, so this is pretty much it. And then let's print this out, and it should print all the values in a descending order, like in an increasing, who is the highest based on that. So uh, did we uh, why, yeah, I'm getting in a descending order, right? Yes, this is the correct order. So here now, if we want the second largest person, the salaried person, then what are we supposed to do? We can simply say, what we can say is second highest salary person, to get a second highest salary person, get of index of 1. That means I should get 104 Vijay 8,000, right? So let's see if we are getting, yes, we are getting this desired output. And this is how we are going to implement the lambda expressions using our own objects. Um, yeah, and I hope you understand and I hope you like this session. Please like, subscribe and share, and please do leave a comment if you have any questions on anything. Please let me know. I will make a very good video for you and then I will publish it. You guys can have those concepts ready for you. Please like, share and subscribe. Thank you and take care. Bye.